Today we will discuss about an example of the previous topic, which was a nodal analysis. So we'll see this example. In this example, we are going to determine V1, V2, and V3. Mean that the potential at this node, and this node. Let's see. We already discussed that nodal analysis we will use both potential and the end but QVL by determine the voltage. So let's go. So in KCL, this node at node 1, this current is entering. This current is entering, and I will consider that this current also is entering here, I1 here, and I will have another current is leaving, I2. So in this node I have this current is entering, I have I1 is leaving, I have I2 is leaving. So I'll have this current is entering is 4 equal I1 plus I2. Now to determine the value of I1, since the current is flowing from V1 to the node analysis V2, I will have 4 equal. The current I1 is flowing from potential V1 to voltage V2. So I'll have V1 minus V2 divided by 3 plus I2. To determine the current I2, since the current is flowing from V1 to V3, I will have V1 minus V3 divided by 2. Now, if this one I multiply by 6 here, I will get 4 multiplied by 6 is going to be 24 equal 6 divided by 3 is going to be 2V1 minus 2V2 plus 6 divided by 2 is going to be 3V1 minus 3V3. Now, why did I multiply by 6? Because I wanted to remove this denominator, this 3 and this 2. So I'll multiply 3 multiplied by 2 is going to be 6. I'll multiply both by 6. So by the end I will found 2V1 minus 2V1 plus 3V1 is going to be 5V1. There is not V2 minus 2V2 minus 3V3 equal 24. Now I determine the first equation. Now at node 2, this node, this current is entering I1. This current is entering, this current is leaving. So I will have I1 plus this current 4Ix equal Ix. The Ix is the current is leaving. This current is entering, this current also is entering, so this current is leaving, equal Ix. By the end I will have I1, this Ix come in this side, I will have 4Ix minus Ix is going to be 3Ix equal 0. Now I will have I1. To determine I1 equal V1 minus V2 as we did here. So I will have V1 minus V2 divided by 3 plus 3Ix. 3Ix, Ix is this one, this current, equal V2 minus 0 divided by 4. It's going to be plus 3V2, because minus 0, no need to put the 0, divided by 4 equal 0. Now, if I want to remove this denominator, 3 multiplied by 4 is going to be 12. So I will have 12 divided by 3 is going to be 4V1 minus 4v2 plus 12 divided by 4 is going to be 3. 3 multiplied by 3, 9v2 equals 0. Now, I will have 4v1 minus 4v2 plus 9v2 is going to be plus 5v2 plus 5v2 equal 0. Now I found a second equation. Now I have to come at node 3. At node 3, in this node, this current I1 is entering, this current is leaving, this current only I4 will be leaving. So I will have I1 equal I4 plus this current was leaving 4ix. For 4ix ix. Now I1, to determine the value of IN as I did in this one, is going to be V1 minus V3. So now V1 minus V3 divided by 2 equal I4. I4, this one is going to be the V3 minus 0. So it's going to be V3 divided by 6. No need to put minus 0. Plus 4ix. Ix equal what? It was equal V2 minus 0 divided by 4. So it's going to be equal plus 4 divided by multiplied by V2 divided by 4. Now I will get this one is going to be equal V1 is going to be equal V1. This 4 and 4 will leave. I will have V1 minus V1 minus V3 divided by 2 equal V3 divided by 6 plus V2. So by the end, if I multiply by 6, this 6, because I have by 1 here, so 6 multiplied by 1 is going to be 6. I multiply by 6, 6 and 2 divided by 2 is going to be 3v1 minus 3v3 equal, this 6 go, remain v3 plus 6v2. By the end, the equation, I will get 3v1, but this 6v2 will come in this side minus 6v2. This v3 come this side is going to be minus 4v3 equal 0. So I found the third equation. So I have 3 equations. I have this equation, I have this equation. In this equation there is no v3, it's going to be 0, and I have this equation, third equation. If I put in the calculator, I will determine the value of v1, I will determine the value of v2, I will determine the value of v3. Now we are going to see also what we call a supernode. A supernode. We are going to see what we call a supernode. But before we start, let's understand some concept. Like if I have this voltage, let's say for example 6 volt, I have this ground here, and here it is V1, mean that there is no any element here. If there is no any element here, mean that V1 is going to be equal 6 volt. 6 volt, because there is no any element, and this one is the ground. So the value of V1, if there is source with the no reference potential node, so the no reference node is going to be the value of the source. Now what we are going to see, what we call supernode. A supernode is like between two reference nodes, two non-reference nodes, there is a voltage source. Between two non-reference node, there is voltage source. There is voltage source. The voltage source can be either dependent or independent, as we see. For example, if I have this circuit 10 volt, I'll have this one, I have this circuit, for example, I have this source, I have another circuit here, and I have this one. So I have 10 volt here, I have 2 ampere, 2 ohm, I have 4 ohm here, and I have plus 5 volt, and I have 6, I have 8. Now, if we see in this circuit, this one, let's say this one 1, node 2, node 3. Here's the reference. The reference, as we see, we say it is the node. Now, this one is a supernode. This one is a supernode. Why? Because a voltage source is between two non-reference nodes. Two non-reference nodes, and there is no any element. There is no any element here. So, to solve this one it is a supernode here, because there is a voltage source. The voltage source can be either dependent or independent. Same. So how to solve this one? And we have to keep in mind that this voltage, as we see here, is connected to the ground, and there is no any element, meaning that V1 is going to be equal 10 volt. Since the voltage source is 10 volt, meaning that the value of this potential is going to be 10 volts, because initially it was V1 minus 0 equal 10 volt, but the 0 no need to put, so V1 equal 10 volt. Now, to solve this one, we'll remove the supernode, and we will use KCL for both node. How? Let's see, we'll see like this one. I have this voltage source plus, I will have this one, I'll have this one, connected this one, I'll have this one, I will have this one, this one. So I have the 2 ampere here, I'll have the 2 ampere here, I'll have 8. Here it was my V2, here it was my V2, my V2 was here, here was my V3. Now I remove the supernode. You have to remove it, and if I remove it, I will use KCL between the two nodes. How? Initially this current was entering here, this current, I have I1 here, I have I1 was entering here, I had this voltage source here, plus minus, and I have this resistor here, I have another resistor here. This current I1 is entering, so since this current I1 is entering, another current here it was leaving, I2 here is leaving, in this current is entering here, I3. This current will come here and come here again, I3, and the I4 was leaving here, So to use KCL between the two nodes, summation of the current entering here, and we'll keep between these two nodes. What's the current entering? The current entering, I will have I1, because I1 is entering in this node. I have to look at also this node. There is current entering here. The current entering here is I3, so it's going to be plus I3 plus I3 is going to be equal, there is no another current entering, equal the current leaving. In this node, which current is leaving? I2 plus I2 equal I2. In this node, which current is leaving? I4 plus I4 plus I4. So I will use the current, I will check the current entered in this node and this node. Summation of the current entered in both nodes equal the summation of the current leaving in this both node. And we use the previous node analysis to determine the potential of this one and determine the potential of this one. In the next video, we will see some example of using the node analysis.